Next, we are going to discuss the area of triangle. So we're going to discuss two formulas. So let's say we know a triangle, and the information that we know about this triangle is the base of the triangle and the vertical height from top to the base, so that vertical height is h. So if you know these two pieces of information, then we say that area of triangle is half base times height. But sometimes you don't know this information. You might have some other information about the triangle. So you might know what are the three sides of triangle. So in that case, you can simply use Heron's formula, so which will give you the area of triangle. So Heron's formula is, so square root of, so there is a special number s, and then you subtract just all the three sides from s and multiply them together. What is s? So s in this case is half of the sum of three sides. So where s is equal to a plus b plus c over 2. Half of the sum of three sides. Alright, so let's try to do some problems where we're going to use our concepts that we just learned. Maybe we can use Pythagoras Theorem, maybe we can use the area formulas. So let's see what we need. So read the next problem carefully. In this problem, what we are given is we want to make a counter in the corner of an office that is 16 feet long. So just like shown here, so they want to make this counter 16 feet long. Find the area behind the counter if the two walls behind it are of equal length. So our goal is to find what is the area that is behind this counter. In other words, we are interested in finding the area of this small triangle that is way up there in the corner. So, and we just learned today that area of triangle is given by half base times height. And in this case, we can see that since this is a 90-degree angle, so, and we have two equal sides, so one side gonna act as a base and another side gonna act as, so let's say this gonna act as base and this gonna act as the height of triangle. So it means if we figure out the area, so the area in this case should be half x times x. So now our problem reduces to finding x. So required area is, so area needed is this much. So I'm going to call this number 1, and now we're going to switch to finding x somehow. So I'm just redrawing my triangle here so that we can have a better view. So in this case, we notice that we have 90-degree angle here. So it is a right angle triangle, and we can use the information about Pythagoras theorem. So using Pythagoras theorem, we can find our x value. So using Pythagoras theorem, we get c squared is equal to a squared plus b squared. So where c is the longer side, a and b are the smaller sides. So in this case, when we solve it, we get 16 squared is equal to x squared plus x square, which implies 16 square is 256 is equal to 2x square. In other words, x square is equal to 256 divided by 2. So we got x square is equal to 128. So x would be square root of 128. So we found the x value and we can plug in this value in number 1. So using x in 1, so using x value in 1, so we got area behind the counter, which is our area needed, is equal to x squared by 2. So it means square root of 128 squared by 2, which in other words is 128 over 2, and we get 64 square feet. So that is the area which is behind the counter, and this is what we were trying to find out. All right, let's take a look at another example. So find the perimeter and area rounded to 3 significant digits of the triangle in the picture. So in this one, we notice that we are given all the 3 sides of triangle, and if you want to find the perimeter in this case, we know that perimeter is simply the sum of all the 3 sides, the sum of the boundary. So in this case, the perimeter would be 9 plus 15 plus 18 centimeters. So total we get 42 centimeters. In order to find the area, so we discussed that if you have all the 3 sides, we can use the Heron's formula. So area would be given by S minus A, S minus B, S minus C. And in this case, what is S? So where S is equal to sum of area perimeter, so sum of all the 3 sides, which is the perimeter. So it's just 42 over 2 in this case, which is 21. So we're going to plug in the values here. So S is 21, A is 15, so 21 minus 15, 21 minus 18, 21 minus 9, and after simplification we got 4,536, which is approximately equal to 67.3 square centimeter in terms of 3 sig figs. So always analyze the problem and then see which formula works best for you. Thanks for watching. In the next video, I will just explain the area and circumference of the circle. So make sure you do watch that one too.